angle measure. We'll start our first chapter of trigonometry learning about angles. This diagram illustrates different parts of a circle that we're going to be working with today. From the center out to the outside edge, hopefully you know that that is a radius. The central angle is an angle that's created from the center of a circle. And many times in trigonometry, Greek letters are used as variables for angles. So in this circle, this is the Greek letter theta. And it will stand for our angle. And then the outside edge that's marked off by our angle is called the arc length, and we usually use the letter S for arc length. Angles are measured in both degrees and radians. In a circle, the degree measure of a central angle is measured inside the angle itself. The radian measure of a central angle is the distance the angle marks off on the outside edge of the circle. It's a portion of the circumference. So remember from geometry that the circumference of a circle is c equals 2 pi r. Well, suppose the radius is 1. Then the distance to go around the entire circle one time is 2 pi, and we say it's 2 pi radians to go once around our circle. In degrees, once around the circle is 360 degrees. So 2 pi radians is equal to 360 degrees. Usually when an angle is measured in radians, we don't write the word radians at the end. However, when an angle is measured in degrees, we have to always write the little degree symbol beside the number. There are times when we have to convert back and forth between, and these are simple formulas. To convert from degrees to radians, you multiply your angle by pi over 180 degrees. Keep your result as a fraction unless the original angle is a decimal. So I want to convert 30 degrees to radians. I multiply by pi over 180 degrees. So degrees on top and degrees on bottom will cancel degrees. And then when you reduce the fraction, cross diagonally reducing 30 and 180, you get 6. So it's pi over 6 radians. If it's negative, it doesn't matter. You still do it the same way, times pi over 180 degrees. And 150 and 180 both divide by 30. So we can reduce that down. Divided by 30 is 5. Divided by 30 is 6. And we have negative 5 pi over 6. Even a large number like 1,260 degrees times pi over 180 comes out even, actually. 180 goes into 1260 exactly 7 times, so it would be 7 pi. Now going the other way around, to convert from radians to degrees, you just flip the fraction, multiply by 180 degrees over pi. So I'm converting pi over 3, multiply by 180 degrees over pi. The pi's would cancel, and 3 would cancel into 180 60 times, so I'm left with 60 degrees. Negative 4 pi over 3 times 180 degrees over pi. The pi's would cancel. 3 goes into 180 60 times, so we're multiplying negative 4 times 60, negative 240 degrees. Now, if you don't have a fraction to begin with, if you've got starting off with a decimal, when I multiply by 180 over pi, I would just put that in the calculator and use the pi button on the calculator. 8.97 times 180 divided by pi, and just round to 2 decimal places, 513.94 degrees. Now here's a circle with central angles labeled 30 degrees, 45 degrees, 60 degrees, and so on. Their corresponding radian value is beside them. So if you're at 30 degrees, the radian value is pi over 6. 45 degrees, the radian value is pi over 4, and so on. And in a later lesson, we'll get more into that. Now suppose we're a little bug and we've traveled around our circle. We've gone from 0 degrees to 45 degrees. And so we could say we've traveled a total of 45 degrees. Now suppose we go past that and we go all the way around and back to the 45 degrees. So now we've traveled 45 plus another 360. We've traveled a total of 405 degrees, even though we ended up back at 45. I could go around again, stop at 45. Now I've gone to 45 plus once around plus twice around. I've traveled 765 degrees. Because 45, 405, and 765 all represent the same place on the circle, these angles are known as coterminal angles. These three are coterminal, and every time we add another 360 and end up at 45 degrees, that's another coterminal angle. When traveling in the circle, we move counterclockwise. That's this way. If we were to move clockwise this way, we would indicate this by using a negative for the angle. So if we traveled clockwise 45 degrees, we would say that we're at negative 45 degrees, which would actually be 315 if we went counterclockwise. So a negative angle simply means we've traveled clockwise around the circle instead of counterclockwise. Coterminal angles can also be expressed in radians. If we're at pi over 4 and we go around the circle again, then we've traveled pi over 4 plus 2 pi. 2 pi is one whole time around. And so the angle, the coterminal angle, would be 9 pi over 4. Now, it's a little bit of a pain sometimes to deal with the fractions when you're doing the radians. So a little calculator trick. If I wanted to add the pi over 4 plus 2 pi, I would just leave the pi's off. And in my calculator, I would type in 1/4 plus 2, and then press enter, and you're given the decimal 2.25. But your graphing calculator will convert back to fractions. So if you push math and then choose option 1, which is a little arrow, and then it says frac, so back to fraction, and then enter, then it'll give you 9/4, and then you'd put the pi back on. So 9 pi over 4 is what you would write. So just leave the pi's off, add it in your calculator, convert it back to a fraction, put the pi back on. To find the coterminal angle that's between 0 and 360, if you're given a larger angle, if the original angle is positive, you'll keep subtracting 360 until you end up with something that's in between 0 and 360. So if I want to get 1234 degrees, back to where it would be on the circle if I hadn't gone several times around, if I was just staying in between 0 and 360, I would subtract 360. That gives me 874. Keep going, do it again. That gives me 514. One more time, subtracting 360, and I'm at 154. So now I'm in between 0 and 360, so 154 degrees is the same place on the circle as 1,234 degrees. It's just the angle that's between 0 and 360. And of course, you don't need to keep writing down minus 360 and the result every time. You would just quickly do that into your calculator until you get the result you want. Now, if the original angle is negative, you would keep adding 360 until you got a positive angle. So negative 574 plus 360 is negative 214, and add 360 again, and you're at 146. Now it's positive, it's between 0 and 360, so that's the coterminal angle that you want. Same idea if you're dealing with radians. If you want to find a coterminal angle that's between 0 and 2 pi, if the original angle is positive, you're going to keep subtracting 2 pi. And again, just use your calculator. Leave the pi's off. Do 25 halves minus 2, and you get 10.5. Okay, I'm leaving the pi's off for now. I get 10.5. Subtract 2 again. 8.5. 2 again. 6.5. Again. 4.5, then 2.5, and then finally I'm at 0.5. That's between 0 and 2. You want it to be in between 0 and 2. And then you want it to be a fraction. So 0.5 is a half. And you want to put the pi back on now. So it would be pi over 2. If your original angle is negative, just keep adding 2 pi until you get a positive value. And again, for now, just leave off the pi. Do negative 3/2 plus 2, which is 0.5. Make that a fraction. That would be a half. And then put the pi back on. So that one would also be at pi over 2. Now the way that the arc length, which is this outside edge I have in red here labeled S, is measured is the formula S equals R times theta. So S is the arc length, R is the radius, theta is the central angle. You have to be careful because theta must be in radians, and if it's given to you in degrees, you have to convert it first and then put it in the formula. So this example, the length of an arc that subtends a central angle of 60 degrees is 20 centimeters. Find the radius. So we've been given S, that's the length of the arc. We want to find R, and the central angle is 60 degrees, but we have to convert it to radians. So it's going to be 60 degrees times pi over 180 degrees. 60 goes into 180 3 times, so it's pi over 3, and that's theta in the formula. Filling in what I have into S equals R theta, I would write 20 equals R times pi over 3. And then to get rid of a fraction in an equation really quickly, just flip it over and multiply. And then put that in your calculator. 3 times 20 divided by pi, and you get 19.1. And it's centimeters is the radius. Now, if we want to fill in the little pi wedge that's marked off by our central angle and our outside edge, then we're finding the area of a sector. And that formula is area equals 1/2 r squared theta. R is the radius, theta is the central angle, and again, theta must be in radians. So now it's saying find the radius of the area, find the radius if the area of the sector is 20, so we've been given the area, and the central angle is 0.5 radians. So there's our theta, it's already in radians. Most of the time radian angles have a pi with them, but they don't have to. So 0.5 is our angle, we don't have to convert it. Filling in the formula for A, we'll put 20 equals 1/2 r squared times 0.5, which really is a half. But I'm going to go ahead and multiply both sides by 2 to get rid of the fraction. 40 equals r squared times 0.5. Divide both sides by 0.5. $80 equals r squared, and then you would square root both sides. Normally when you square root both sides of an equation, you have to put plus minus in front of the answer, but you can't have a negative radius, so it will just be the positive root, 8.94. And we don't have any units given to us, so 8.94 is the radius.